Today we're going to take a look at telling the difference between mutually exclusive and inclusive events. So remember, what you want to do is ask yourself, can both events happen at the same time? If the answer is no, they're exclusive events. If the answer is yes, then they're inclusive and you'll have to subtract off that overlap. So let's take a look at our first example, talking about rolling a prime number or a number greater than 5. So first of all, can that happen at the same time? Well, on a die, the prime numbers are 2, 3, and 5. And the numbers greater than 5 are 6. Well, there's no number in both lists, so these are exclusive events. So when we calculate the probability of exclusive events, we simply add the probabilities together. So we get 3 out of 6 plus 1 out of 6 for a total of 4 out of 6, which simplifies to 2/3. Next, we're taking a look at a bag of M&Ms. Can we pick one M&M out of the bag that is both red and brown? No. So these are mutually exclusive, so we're simply going to add the probabilities together. There are 13 red M&Ms out of 45 total M&Ms. Or, so we're going to add, there are 8 brown M&Ms out of 45 for a total of 21 out of 45. Next, we're taking a look at the probability that a chosen member of the math team is a boy or a senior. Can a person be a boy and a senior at the same time? Yes, so these are inclusive events. So we are going to take the probability of a boy, and it says there are 14 boys out of, we have 20 girls and 14 boys for a total of 34 people on the math team. Or a senior, it says 7 of the girls are seniors and 4 of the boys are seniors. So there's a total of 11 seniors out of 34 minus those senior boys. So in this case, we have 4 boys who are seniors. So that gives us a total of 21 out of 34. For our final example, we're looking at a bunch of different cars in a parking lot. So the question is, can a car be both black and a truck? The answer is yes, we have black trucks. So these are inclusive events. So we're going to start with the probability that we get a black car. So we have 4 black SUVs, 6 black trucks, and 18 black cars. So that gives us a total of 28 out of 64 vehicles in the parking lot. Plus, probability that it's a truck. So we have 3 red trucks, 6 black trucks for a total of 9 trucks out of the 64 vehicles, minus those 6 black trucks that we counted twice for a total of 31 out of 64. Here are your 2 U-Try questions.